Hello and welcome. This is Appen and our presentation on Human-Centric Benchmark for Voice Assistant Evaluation. I am Ilia Shifrin and I'm Senior Director of AI Specialists here at Appen. My team is the backbone of the Solutions and Advanced Research Department leading this initiative. Active supporters and sponsors of this program at Appen are David Brunel and Dr. Ming-Kwan Liu, as well as Dr. Judith Bishop with Marks Institute. I will be presenting to you today. First, I'd like to introduce Appen. Appen has over 25 years of experience in the language technology and AI industry. Appen's mission is to serve the whole of the AI lifecycle through its comprehensive suite of products. Appen's products offering cover all AI application development needs, from data sourcing, data preparation, model build and deployment, to the subject of today's presentation, model evaluation by humans. We have observed over the course of Appen's 25 years that the human evaluation of ASR, TTS, and now voice assistant models rarely reflects the complexity of the real-world deployment conditions. These conditions are becoming increasingly complex as the range of users, use cases, devices, and environments multiply, with each of these aspects interacting with each other. Today, we are presenting Appen's Global Voice Assistant Benchmark. Our benchmark product is designed to provide insightful feedback to support model tuning for better real-world performance in diverse user settings and environments. So, why a benchmark? What does a benchmark accomplish that other modes of evaluation don't? A benchmark provides transparency to all contributing parties and public at large. The issue we see is that current ad hoc internal benchmarking practices in the voice assistant industry are hiding shared challenges and hindering shared progress. We believe that a benchmark that provides visible rankings to all on key dimensions of voice assistant performance will lift assistant performance across the board. This is especially important as voice interoperability initiatives mean that multiple voice assistants will be vying for engagement on the same consumer devices. Having directly comparable performance data between voice assistants will benefit all participants in the benchmark. Appen partners with top global technology companies for ad hoc DTS benchmarking and associated ratings. Today, we see an opportunity to streamline, standardize, and iterate the human model evaluation process for voice assistants. A voice assistant benchmark will highlight optimum standards across devices and brands. But why a human-centric benchmark? Simply put, human users are moving targets. As voice assistants become interoperable, smarter, and are used in ever-expanding contexts, it is becoming critical to anticipate and evaluate human dynamic responses to these changes over time. And this includes effective responses or feelings and adaptive behaviors. Here's an example of a human interaction. I'll let you read it for yourselves. As this example shows, human beings will infer language and knowledge competency from even the briefest verbal exchange. We dynamically adapt our responses as interactions unfold. Similarly, users aren't passive consumers of voice assistant outputs. Rather, human beings are constantly updating their mental models of what a voice assistant can and cannot do with every interaction. As AI models evolve, so do our mental models. Based on these mental models and associated feelings, positive or negative, users will decide over time whether to continue their use of a voice assistant. That's why it's important to track human responses in a consistent manner over multiple interactions and over time. Over the 25 years since it was founded, Appen has witnessed the evolution from model-centric AI to data-centric AI, as described by Appen authors Wilson Pang and Alyssa Simpson-Rockwerger in their book Real World AI. Human-centric AI is the next horizon, and human evaluation is an essential bridge to human-centric AI. Automated assessments will, of course, be important to our AI future. We know there's a direction of research, for example, that's looking to automate mean opinion score ratings of TTS voices, and TTS is one core component of the voice assistant product. But we also see this being ongoing value and necessity to human evaluation of AI models. This is particularly the case for voice assistant models, given that these products are specifically designed to serve human needs, whether for entertainment, information, action, or connection. Let's consider for a moment the size of the voice assistant market. It is already extraordinarily large, but it is set for future growth as voice assistants move beyond the home, car, and mobile contexts to take up residence in workplaces, retail settings, hospitals, aged care residences, and other service contexts where voice assistants are embedded in the organizational fabric of relationship, knowledge sharing, communication, and connection. Amazon's smart properties is leading the way for Alexa and smart devices to be distributed and coordinated by business owners across a range of verticals. This focus on voice ecosystem development could massively expand the range of use cases for voice assistants. There are a range of figures out there on the web around the number of voice assistant users and units both in the United States and globally. The ones we've provided here are just a selection. Their exact precision is difficult to vouch for, but the scale is undeniable. Also worth noting is the apparent massive global user base for voice assistants, which, if accurate, dwarfs the United States user base. If the need for standardized evaluation of voice assistant performance is acute for United States English, as we believe it is, imagine the scale of the evaluation problem across more than 100 languages currently served by commercial voice assistants. Poly AI, for example, claims more than 100 languages for its voice assistant product. And yet, even for diverse segments of United States English speakers, there is an exceptionally poor amount of data available on voice assistant performance. Consistent data at scale on voice assistant performance for diverse populations appears to be absent from public view, if not lacking altogether. Research studies in recent years have focused on populations where voice-related bias is already visible. These studies have brought the issue to broader public attention, but we believe that even this research hardly scratches the surface of the variability in performance for intersectional linguistic and demographic minorities that a larger scale benchmark would bring into view. Clearly, there's a need for better voice assistant evaluation data at scale. But what does that look like? Based on our expert literature review and conversations and projects with our customers who range from enterprise developers to the top major global technology firms, we propose to evaluate voice assistants' performance along 4 key dimensions, both current and emerging: agreeableness, accuracy, acceleration, and adaptability. Looking first at agreeableness, we know that TTS evaluation have traditionally focused on the naturalness and pleasantness of the generated voices, which is to say, the human effective response to the voices. We call this dimension identity. Research shows that the likability of a voice can depend on the identity of the listener. To take an Australian example, we found that listeners with a broad Australian accent prefer to listen to a voice with a broad Australian accent. So identity is one subdimension of agreeableness, but we believe other dimensions also contribute, namely memory and empathy. Memory can be thought of as what provides the continuity of relationship with a user, while empathy is the basic ability to detect and respond appropriately to a user's state of mind, as inferred from the verbal interaction. The second key dimension is accuracy. ASR evaluations have traditionally focused on accuracy, while natural language understanding evaluations have addressed how well a user's intent has been captured by the system. We think that a further emerging but very important dimension of accuracy is the quality and relevance of the knowledge or information conveyed by the voice assistant. The third key dimension is acceleration. When the Vice President and Chief Operating Officer at Amazon Alexa talked about the importance of a frictionless user experience at the Amazon Alexa Live event in 2020, she was addressing this dimension. We prefer to call it acceleration to name this positive and aspirational quality of voice assistants. Acceleration essentially addresses the question, is it easier and/or faster to accomplish this task using a voice assistant? As neuroscience research has shown, human beings are acutely sensitive to increased effort and delayed response times. We have a strong tendency to associate negative effect with more effortful experiences and slower response times. As Amazon has recognized, acceleration is critical to increased voice assistant adoption. This dimension is not all about the assistant's performance, however. By including this subdimension of pace, we acknowledge that when an interactive system expects a faster user response than it gets, that too creates a situation where reaching the end goal is more challenging for the human. Speech research has shown that older adult speech is generally slower. For older speakers and also users with a stutter or other speech impairment, timeouts can significantly decelerate their voice assistant interactions by making the user repeat and repair the broken interactions with the assistant. This is incredibly frustrating. Little wonder that an older research subject in one Australian study is cited as saying, "Tell Google to behave. All she gives me sometimes is angina with frustration." The final and most future-oriented dimension is adaptability. As interoperability of voice assistants and smart devices increases, an important dimension of performance will be whether the assistant keeps you connected through the transitions. For example, how well the voice assistant on one device carries over information as you move between, say, your smart speaker, mobile phone, and car while carrying on an interaction. Proactive anticipation of user needs and responses that are pragmatically appropriate to the situation of the interaction, including time of the day and location, will also be important as voice assistant intelligence approaches more human-like intelligence. To take just one example, the activity recommendation or product suggestion that are offered late at night shouldn't be the same as those suggested when the user is getting ready for work in the morning. These are all components of the voice assistant experience, but the overall experience is a combination of these. A benchmark that comprehensively assesses all dimensions using both subjective Likert scale rating and objective linguistic and device data with insightful expert analysis of these will provide the best possible overview of voice assistant performance and its development over time. But voice assistant evaluation data must also be comprehensive and collected at scale. On this slide, we give an overview of the evaluation design elements in our voice assistant benchmark. At the top is the sampling rationale. The example provided is for the African American language-speaking population in the United States. Research has shown that this population has at least 10 regional clusters of linguistic variation. Rather than sampling the population based on population density, which favors urban centers and overlooks the different density and distribution of linguistic variants, we propose to sample each of the 10 main regional clusters of linguistic variation equally. Then, within each cluster, we propose to target intersectional demographic variations while ensuring that the older adult population is well represented within the sample. Typical sampling methods limit the sample of older adults, say, to a maximum of 10% of the sample, in line with assumptions about consumer spending habits. The smaller sample size leads to poorer model performance due to relative data paucity. In a world where voice assistants will be used well beyond the consumer device market and will come to play an important role in the aged care and healthcare sectors in particular, this poorer performance will have adverse effects on the success of voice assistants in these sectors, unless performance is measured and leveled up across all user populations. In the middle boxes in this diagram, you can see an indicative evaluation design with the number of intents, prompts per intent, device suggestion, and a novel time of day parameter that's designed to assess the dimension of adaptability that we discussed on the last slide. The number of intents will vary depending on the skills, actions, and other functionality to be tested. All prompts and utterances and device responses will be recorded using the Appen mobile recorder on a smartphone. In addition, benchmark customers can choose to make available device data such as ASR recognition records or system-generated responses for inclusion in the benchmark analysis for their dataset. Likert scale questions will target the 4 key performance dimensions mentioned on the previous slide. Each benchmark customer's data results will be made available only to that customer, with overall rankings and broad insight being publicly displayed. Finally, we propose to use a combination of semi-automated and targeted linguistic analyses to provide actionable insight into the causes of voice assistant interaction failure for each intersectional demographic included in the benchmark. Subjective ratings alone fail to provide this essential bridge between user sentiment, device performance, and users' actual verbal behavior. These insights can therefore help to target more precise data collection needs for fine-tuning assistant performance. Finally, better voice assistant evaluation data is necessarily longitudinal. Voice assistant models and functionality are constantly being updated, and user expectations and verbal behaviors are also in constant evolution. A longitudinal benchmark provides a standardized framework for evaluating voice assistant performance over time and tracking performance as new skills and functionality are introduced. For this reason, we propose a flexible quarterly or half-yearly schedule of benchmark iterations. This design provides the opportunity to analyze nuance within demographic groups. At the same time, phasing in key benchmark populations over time allows flexibility in the choice of target populations and the opportunity to compare nuances in performances between demographic groups as well as within. Our major technology developer customers have told us that compelling performance data is essential for them to drive the business case for engineering investment to improve performance for diverse, intersectional populations. We believe it's important to understand the problem in depth and use targeted data collection to fine-tune models to address the actual issues, rather than just throwing larger volumes of open-source data at the problem. While larger datasets can address some of the issues, these datasets may not be representative of gender, age, ethnic, or linguistic diversity. Speech and language data on the internet, for example, needs careful filtering and categorization to ensure that demographics of the interest are represented by the data. Appen has proposed a solution to this issue in a forthcoming paper. We have talked a lot about diversity, but to finish up, we'd like to dive a little deeper into the issues that two specific populations of voice assistant users face, namely the African American language speaking population and the older adult population. In 2020, researchers at Stanford conducted a study of major ASR engines' performance for African American language speakers. As shown in the uppermost left box, the disparity in the ASR performance as measured by average word error rates for black and white users was stark. Recognition errors were compounded by dialect strength, gender, with male users being more poorly recognized, and age. The top middle box shows how even a common feature of African American language, the habitual b, as in I be sittin', isn't recognized by the ASR engine. In a 2021 research study, Zion Mengesha and her co-authors provided powerful evidence for the negative well-being impacts on African Americans by poor ASR performance in voice assistants. The 30 participants expressed a range of strong negative emotions arising from their use of the technology. Studies such as these have been essential in raising awareness of these issues. But to truly shift the needle on performance, we believe longitudinal evaluation of performance for intersectional linguistic and demographic groups is needed to provide feedback and to monitor progress over time. There's a lot of excitement currently around the potential for voice assistant devices to support care and connection in senior living and residential settings. And little wonder, since 4,600 people turn 65 every single day in the United States alone. Research last year showed that voice assistants are a promising tool for older adults to maintain and enhance social participation, autonomy, and leisure activities. Stigall and colleagues cited research suggesting that with vision and fine motor control becoming more challenging for older adults, audio is a modality of choice for older adults without hearing impairments. Amazon is one of the leaders in promoting voice assistants to alleviate loneliness and improve the care experience through Alexa smart properties. However, evaluation studies of voice assistants' performance for older adults, especially ASR and NLU engines, are even more scarce than for African American language speakers. This is despite there being ample research evidence showing that age-related physical and cognitive changes can affect speech and language production, thereby also impacting ASR and NLU engine performance. Word error rates for all ASR engines tested showed a minimum of 1.6% word error rate for 20 to 60-year-olds, 3.7% for over 60s, 5.79% for over 70s, and as much as 14.2% for over 80, demonstrating a clear impact of age on performance, and this was for one of the best performing engines. To shift our focus now, you may be wondering how Appen will engage relevant community members to participate in our benchmark. Clearly for African American language speaking populations, but also all other diverse and intersectional populations, gaining community trust is paramount. We believe the longitudinal nature of the benchmark provides a good foundation for building trust by providing guaranteed repeat work over an extended time period, with the voice assistant device remaining with the participants as the added incentive. In addition, we provide comprehensive incentive design and investment in progressive community management by members of the community. In this way, we're confident we can engage Black, older adults, and other linguistically diverse communities to participate in the benchmark. This, then, is how we see voice assistant model development happening over time, and the contribution that a standardized longitudinal benchmark will make to the development. We're currently at a point in time where visible areas of demographic bias are being spotlighted by high-profile studies of broad demographic categories, such as African Americans. But to truly ensure that every user is well served by this technology, we need to go further. We need to ensure that voice assistant performance is optimized even for finer intersectional categories of user. This will become increasingly critical to the ethical and inclusive deployment of voice assistants in ever-broadening context of use, including health, aged care, finance, and education. In our presentation today, we've argued that the dynamic range of human responses to AI products is insufficiently addressed by current model-centric and data-centric AI perspectives. A human-centric perspective will be essential to future progress. Human effective and adaptive responses contribute to the well-being impacts of voice technologies. The performance of voice assistants can either support or undermine feelings of social inclusion and verbal or voice-related adequacy. Difficulties in using the voice to access functionality or services reinforce negative effects arising from existing social biases, including race and age. Responding to the call for ethically aligned design, Appen's Global Voice Assistant Benchmark provides a comprehensive, systematic, and longitudinal framework for assessing, understanding, measuring, and monitoring the impacts of assistant performance as voice assistants continue to evolve over time. And this concludes our presentation. We thank you for your attention and hope you found this information useful. If you're curious to learn more about our research on inclusive and personalized AI, or want to become a member of Appen's Global Voice Assistant Benchmark program, please reach out to me directly or contact David Brudenell. Thank you and have a great day.